Greetings, animal lovers! Today's video is about turtles and their majestic glory. See how happy he is? He's actually kind of surprised. I don't know why. Maybe he saw something in the ocean. The ocean can be a scary place, but also an extremely beautiful place. If you haven't guessed it by now, it is Mr. Benjamin here. And today's lesson is actually about congruency and similarity. These words, kind of sound a little weird. Similarity, we should know what that means. But congruency? It sounds like a meal that you don't want to eat. That's a congruent sandwich. It doesn't sound right. But we're going to talk about it anyways. I don't know what that's supposed to be. It's supposed to be a star, but it's okay. There we go. So our learning goals for today, we are going to investigate the conditions that make two shapes congruent or similar. Okay? There are specific conditions that we need to know that will help us determine whether two shapes are, like I said, congruent or similar. So in order to know what these shapes are, or if they're congruent or similar, we first should know the definitions. Similar shapes, so shapes that have the same interior angles. Alright, now if we think about a square, for example, and I know that looks more like a rectangle, but it doesn't really matter because I'm going to get the same point across. Every interior angle of a square or rectangle is 90 degrees. We know that because these lines are perpendicular. When they intersect, they form a 90-degree angle. Now, it doesn't matter if I draw my square or rectangle as a diamond. It still has 90-degree angles. Now, a triangle will not have 90-degree angles. These angles are different. These are 60 degrees each, if it's an equilateral triangle. A pentagon, I'm not that great at drawing pentagons. There you go, that's okay. Those two are 90 degrees. This one's going to be a bit less, a bit less, a bit less. You can have pentagons that are a bit more shapely, I guess. Kind of like that. And all of these angles will be the same. But they won't be 90 degrees. Only the square or the rectangle will have 90-degree angles. Okay, let me see if I can get congruency in here as well. Congruent shapes. Shapes that have the same interior angle and side lengths. So although this square here, or rectangle here, and this rectangle here have the same interior angles, their side lengths may not be the same. So if I draw another triangle over here, and another triangle here, the interior angles are ideally the same, but the side lengths are not. This could be 3 centimeters, while this is only 2 centimeters. Okay, so these would not be congruent. Not congruent. So a lot of you are probably saying, what's going on? I don't understand. Now, if you know me, and you probably should by now, I'm a very visual learner. I like using images. So if we look at these fine-looking turtles here, now obviously I didn't draw these. Someone who knows how to draw drew these. These two turtles up here, let's get some nice straight lines that don't connect. These turtles are congruent. They're facing a different direction, but don't worry about what direction they're facing. If I were to cut this turtle out and bring him over here and place him on top, he would line up perfectly. Okay? Be right on top of him. Tail, shell, eyes, mouth, everything. He would line up perfectly. These two turtles down here, whoops, although they still look the same, they do not have the same measurements. This turtle is much smaller. It's very hard to trace. Although I kind of got it. Happy face. Yeah. And this turtle is much bigger, much easier to trace. If I were to cut out the smaller or the larger turtle and try to put them on top of the other one, it would not fit. So, same measurements. Well, I'm not going to be able to fit that. Okay, I'm going to erase it and write it again. Therefore, remember the 3 dots is therefore congruence. Over here we have different sizes or measurements. Sizes is easier to write in this case. Therefore, similar, not congruence. So let's look at another picture of adorable turtles. These are, I'm assuming, baby turtles, not miniature turtles, because I've never seen a miniature turtle in my life. These 2 turtles here, what do we think? Do we think they're congruent or similar? Take a minute, look at them. They look very, very, very close to each other. Don't worry about this third one in the background. He's hiding in a shell and he's out of focus, so we're not going to worry about him right now. If you ask me, these 2 are not congruent, but they are similar. Two reasons for that. First of all, they're 2 different beings. They're 2 different living creatures. So unless they were born as twins, which very unlikely that would happen, they would not be the same. Okay, they're not congruent. However, they are very similar in the sense that their shell shape is the same, their head, their arms, everything. Very, very similar, but not congruent. Now, if I were to take one of the 2, say I were to take this guy here, and clone him, and I had an exact copy, then it would be congruent. But he's not. He's not an exact copy, right? He's his own. So these guys are similar, but not congruent. But they are also adorable. Let's look at an example using some images. I have 2 sets of triangles here. Triangles there and triangles here. Which do we think is similar? Which do we think is congruent? Well, if we look at these first 2 triangles, we've got a triangle. This one is approximately, what, 1, 2, 3, 4, 5 centimeters in length. And this one is 1, 2, 3. 3 centimeters in length. If we look back to our definitions, similar shapes are shapes that have the same interior angles. Congruent shapes are shapes that have the same interior angles and side lengths. So these 2 triangles here, I can guarantee you their interior angles are the same. I know because I drew them. But their side lengths are not the same. So since their side lengths are not the same, they are similar, but not congruent. Now, if we look at these 2 triangles here, they're kind of facing the different direction. This one's kind of more upward, this one's kind of more sloping down. But we're still going to count them out. 1, 2, 3, 4. 1, 2, 3, 4. They're both 4 centimeters in length. Let's look at the other side, their height. 1, 2, 3, 4. 1, 2, 3, 4. They're both 4 centimeters in height. And their interior angles are also the same. So we have, I'll write it up here, same length, height, and I'm going to get rid of that. Actually, what I'm going to do is I'm going to copy it and move it over, because I can. Done. And interior angles. Therefore, we can say they are congruent. I apologize if this is cut off, but I'll write it on top. Similar, congruent. Now we're going to look at an example using words. So, we have an equilateral triangle, which I spelled wrong, obviously, because I do that all the time. Equilater, I'm just missing the AL. Equilateral triangle with side length of 4 centimeters. Now, an equilateral triangle, if you didn't know, is a triangle where all four sides are the same length. Side equals 4 centimeters. And also, on an equilateral triangle, all interior angles are 60 degrees. So, if we have two of these triangles, let me just copy this one. I'm going to put it right here. Bam. Two of the exact same triangles. Side length is 4 centimeters. Interior angle is 60 degrees. Would those be similar or congruent? They would have to be congruent. They're virtually identical. So these are congruent. That's a pretty straight line. I drew that freehand. If we look at our second example, say this is A, this one here is B. If we have two isosceles triangles, an isosceles triangle looks like this. The two side lengths are the same, and the base is different. With interior angles of 30 degrees, 75 degrees, and 75. So we'll say that this is 30 degrees, and these two down here are 75 degrees. Now, it doesn't tell me how large or how small the side lengths are. So my second triangle, I'm going to draw the second triangle right here, could be much, much bigger. Now the angles are still the same. 75 degrees, 75 degrees, 30. So are these two triangles, this triangle here and this triangle here, are they similar or congruent? Well, if the side lengths are different, they would have to be similar. Or not a therefore, because I didn't put a statement. Equals congruent. Whoops, sorry. Whoop, made a mistake. Similar. They are similar because their side lengths are different. Their angles are the same. They're both isosceles triangles, but they're not a replica. They're not an exact copy of each other. They are similar. So for your try this, you are going to draw two quadrilaterals. A quadrilateral is any four-sided shape. Four-sided shape? Four-sided shaped object. 2D object. So it could be a square, could be a rectangle, could be a diamond. There's a couple others I can't think of right now. Any of these, draw two of them that are congruent. Okay? Congruent meaning everything is the same, basically. And two pentagons. Remember, pentagon, I'm not very good at drawing these. Yeah, mine are always off. There you go. That one kind of looks like a house, right? See? It's also a smiley face. Draw two pentagons that are similar. And I want you to explain how you know that you are correct. And as always, we say thank you. And we're going to use a little help with our friends, or from our friends. And he is actually saying, let's move him over a bit. Select, move him here. Done. And we'll draw a thought bubble, or just a vocal bubble. Saying, thank you. Smiley face. That kind of looks off. I'm going to move that down. It should be like down here, basically, I guess. Yeah, that kind of looks okay. Anyways, 14 minutes. Another long video. I apologize. Hopefully we got this. If not, you can always comment, ask questions on the classroom, email me, and we'll be good. Have a great day.